Hello. So you have some data. You might have measured it by looking through a paper too, but you might have measured something else. Desmos provides a really great way to fit different families of functions to your data. How it does it is also really interesting, and maybe I'll tell you at some point. But right now, you might know this already, but if you don't, I just want to show you how to make Desmos do the fits. So here is my fake tube data. No, I don't think this is fake. I think this is my real tube data from 2 years ago. So on the x-axis, we have the distance that my paper tube was from the board in inches. On the y-axis, we have the calculated area of the board that I could view through the tube at that distance. All right, so how do I fit a curve? So notice all the x values are in this list x1. And here I could hide this, and actually if you want to, you can just view, see it says x1 is a 6-element list. I think I can access individual elements, yeah. So using square brackets, I can say element 1, element 2 is 8, element 3 is 15. So it's sort of like, let's get the third thing in the list. Okay, and then the y values, similarly, are a list. So let's say I want a linear equation. So linear equation, one form is y equals mx plus b. So what we want to use is we want to use our, instead of having x be a variable, we want x to be our data. And instead of y being a variable, we want y to be our data. So we'll replace this with x1 and y1. You just have to hit 1 and it creates a subscript automatically. And then instead of saying they're equal, we want to use a tilde, which you get by pressing shift and the button in the very upper left-hand corner of your keyboard. And this is going to do regression, which is a fancy word for fitting a curve to data. All right, here, let's redisplay our points. So this is now the line that will fit the data the best. And if you want to know what value of m does that, you can see it right here. And if you want to know what value of b does it, you can see the b value right here. And so if you wanted to like replot this as its own equation, you could say y equals 7.7x minus 36.7. And you see we've recreated that same line. Excuse me. It also gives you some statistics, some r and r squared, and we'll talk later about what that is. So let's hide this for now, and let's fit some other families. So what if we wanted to do a quadratic family? So we'll do y1, and then instead of equals, we'll say tilde. So you could do a quadratic family that was ax squared plus bx plus c. But again, I don't want x, I want x1, which is our data. So every time x appears, I'll use x1 instead. So that looks a lot better. Let's change this to be cubic. So a cubic general formula would be ax cubed plus bx squared plus cx1 plus d. So the cubic fits, even better. R squared of 0.999. How could we possibly get better than that? Let's do another one. Let's do an exponential function. So tilde. So we could do a times b to the x plus c. But again, I want x1 for my data. And so here's an exponential function. Okay, so go ahead with your own data, fit a couple of different curves. It's not helpful to look at them together. It's more helpful to look at each one individually. And then we'll talk about how can you decide which ones are good.